8, 9, 10, 11, 13, 14, 15. Boa tarde a todos, sejam bem-vindos ao quarto dia da programação da Semana Acadêmica de Engenharia 2021, cujo tema principal é Inovações e Tendências Tecnológicas. Em sua quarta edição da Semana Acadêmica de Engenharia, contamos com o apoio de diversas entidades, o CREA Paraná, o Grupo IDD, o Instituto Lactec, a Pontifícia Universidade Católica do Paraná, a Sociedade Mineira de Engenheiro, Unicesumar, Unicuritiba, Universidade Federal do Paraná, Universidade Tecnológica Federal do Paraná e Universidade de Curitiba do Paraná. O Instituto de Engenharia ele está a caminho do seu centenário, isto é, estamos com 95 anos de existência e buscamos sempre construir vínculos fortes em torno da ética e do profissionalismo. Reunimos engenheiros, arquitetos, geólogos, geógrafos e meteorologistas, contando hoje, novamente, com mais de 4.000 associados. A gente busca continuamente a renovação de ideias, a elevação da qualificação profissional, a criação de vantagens competitivas, fomentando o aprendizado e a troca do conhecimento, assim como a interação entre os profissionais. Torne-se um associado do Instituto de Engenharia e aproveite os benefícios da sua representatividade, que tem princípio em valorizar a engenharia paranaense e, por que não dizer, brasileira. Acesse o nosso site iep.org.br, onde você vai ter todas as informações a respeito da associação. Agradecemos as presenças dos diretores, conselheiros do Instituto de Engenharia, assim como os coordenadores de câmaras técnicas, ex-presidentes, representantes de classe. Nossa semana acadêmica, que se iniciou na segunda-feira, dia 16 de 8, continua hoje com 3 palestras, Então, às 17h30, palestra Materiais Especiais, a palestra agora às 11 horas, que vai ser apresentada na sequência pelo professor Sérgio Cir, que vai fazer a apresentação do nosso palestrante, o professor Rafael Sacks. Às 17h30, então, nós teremos a palestra Materiais Especiais para a Indústria Automotiva, ferros fundidos de alta resistência. Às 19 horas, encerrando o nosso evento, teremos a palestra Inovações do Setor de Energia, com o palestrante Lourival Lippmann Júnior. Da palestra anterior, não anunciei o palestrante, é o professor Giuseppe Pintaldi. Convido todos a participar de todas essas outras, as últimas palestras, para tanto acessem o www.iep.org.br. Sobre os certificados, informamos que a orientação referente à emissão de certificados será passada ao final da palestra de hoje. Passo a palavra para uma breve saudação ao diretor técnico do IEP, Rodrigo Pascoal. Obrigado a todos pela presença.
Obrigado, Nelson. Thank you, Nelson. We are kind of mixing English and Portuguese. We are starting to refer to our guests, so I'll talk in English. Here in IEP, we do have lots of interesting talks coming. Some of these are free of charge, and we offer certificates upon request. In September, for example, we will have a talk directly from Amsterdam about the first 3D printed steel bridge of the world. Please see our website for details. Also, I'd like to say that the first talks of our academic week are available in our channel in YouTube. In 3 days, we have more than 5,000 visualizations and interactions from people of at least 16 Brazilian states and from abroad. This speech will be there in a couple of days. Well, I'd just like to say that it's a pleasure to have you here, Rafael, and also it's an honor to be in the same screen with our renowned professor, Sérgio Cir, who will take control of this event from now on. Sérgio, please.
Thank you, Professor Nelson Gomes, my professor later, earlier. Thank you, Rodrigo. First of all, I would like to thank the partnership with the Brazilian Technion Society in the name of Clarice Fuchs, that we'll talk a little bit, and also to the Curitiba Agency of Development and Innovation, in the person of Alessandra. Please, Clarice, tell us something.
Bom dia, obrigada pelo convite. Eu sou a coordenadora da Associação de Amigos do Technion aqui no Brasil, que é uma das várias associações de amigos do Technion que existem ao redor do mundo. Nós somos uma entidade sem fins lucrativos que tem a missão justamente de conectar o Technion com o Brasil, com estudantes, professores e entidades brasileiras. E, junto com a sociedade brasileira em geral, promover a cooperação entre o Technion e as entidades públicas, privadas, de pesquisa, educação, inovação, e gerar um impacto econômico, social e científico positivo para a sociedade brasileira. Também pretendemos ajudar os alunos de graduação, pós-graduação, que possam ter interesse em frequentar uma das mais prestigiadas universidades de tecnologia do mundo. Ao fazê-lo, nós da Sociedade Brasileira, da Associação Brasileira de Associação de Amigos do Technion Brasil, estaremos contribuindo com a sociedade brasileira, criando relações positivas e de longo prazo entre as instituições do Brasil e o Technion. E eu fico muito feliz de ter o professor Rafael Sacks palestrando hoje para o Instituto de Engenharia do Paraná. Muito obrigada.
Thank you, Clarice. Please, Alessandra, can you talk a little bit?
Olá, bom dia a todos. Primeiro, queria agradecer muito o Technion e o Instituto de Engenharia do Paraná por proporcionar essa palestra tão importante para o nosso ecossistema. Eu sou a Alessandra, arquiteta e urbanista da Agência Curitiba. A Agência Curitiba hoje trabalha com o nosso grande projeto de cidade, né, o Vale do Pinhão, para fomentar o crescimento de Curitiba, o crescimento econômico e social, desenvolver Curitiba como uma cidade inteligente, e a gente tem um trabalho muito próximo com empreendedores e startups, e é um prazer apresentar esses novos temas, né, trazer esse diferencial de inovação, tecnologia, a construção, que é um tema muito importante, né, tem muitos empreendedores e startups trabalhando nessa área, então a gente agradece muito essa oportunidade, abrir um pouco mais a visão do Vale do Pinhão, né, e trazer essas parcerias internacionais também. Então, obrigada a todos os professores. Thank you, Rafael, for joining us today. Have a great Palestra.
Okay, thank you. Thank you for this partnership again. And it's important to note that the Engineering Institute of Paraná is organizing this week, and we add this important speech from Professor Sacks. Well, let me introduce Professor Rafael Sacks. He has an impressive career if we think about research, consultancy, and publications. He's professor in the Israel Technology Institute of Israel, Technion is the nickname, let's say, and has a rich history in collaboration with a number of universities around the world. Besides a number of papers published, he is a co-author of two important books. The seminal BIM Handbook, here in Brazil is called Manual de BIM, that is now in the 3rd edition and is available already in Portuguese. And the other book is Building Lean, Building BIM, with a very interesting description of implementation of Lean and BIM in a Tidhar Experience, a construction company in Israel. Well, Rafael Sacks came here to Brazil a number of times and has a bunch of admirers and friends in Brazil. I myself. He's a gentleman, he's an engineer, he's a scientist. I would like to say that I miss very much the coffee break hours during the events around the world, in Brazil as well, when we met together and talk a little bit about everything. Thank you, Rafael. Thank you very much to be together today. Thank you for sharing this live moment, your lecture, and your thoughts. Please, the stage is yours.
Well, Sergio, thank you very much. Thank you to Nelson, Alessandra, and Clarice for the introductions, and of course for the organization of the lecture today. It is for me also really quite poignant to have to give this lecture online. Of course, we're used to giving lectures online over the past year and a half, but Brazil is one of my favorite places to visit. And so there is a sense of missing out of an opportunity to visit you in Curitiba and in Paraná today, perhaps sometime next year or the year after. I want to talk today about a topic that has to do with digital twins. I hope that you're now able to share my screen as well as you're able to see my screen.
It's okay.
Yeah, great, thank you, Nelson. So as you can see, I've given the talk the title Research and Development Toward Digital Twin Construction. And you'll notice that, well, the R&D is fairly standard, but instead of calling it digital twins for construction, we now are beginning to call this DTC, or digital twin construction. And very much I will try to explain what we're doing in terms of research, but also to give you the sense that we envisage a future world in which certainly many companies will be able to have a new way of building, a new form of construction that we can begin to call, or imagine to call, a digital twin construction. And so a lot of what I'm going to talk about today is the topic of a research project that we currently have underway, funded by the European Union. And the project is called BIM to Twin. It has in total 17 partners, including 5 universities, 3 major construction companies, 5 software companies, and some others. Amongst our partners in the project are the Technical University of Munich, the University of Cambridge, Aarhus University in Denmark, construction companies like Spada, like Acciona in Spain, and like Firo from Finland, and many others. And so as I begin, I want to recognize my colleagues in the BIM to Twin Consortium, who are, of course, deeply engaged in this project. It's a 4-year project, and we're still in the first year of the research. So perhaps in a few words, just to begin, what are digital twins in construction, and why is this something different from BIM or from other technologies? Well, the fundamental idea about a digital twin is that it is a digital representation of a physical reality. And so it may be of a bridge once it's complete, but it may also be of a project under construction. And so we have this physical site, and we have the digital twin that represents that site. But there are 2 ways in which they interact. The first way in which they interact is that we monitor the site using a range of technologies that I'll go into in a moment, to try to build up a picture or a model of what is actually happening minute by minute on the site, and represent that in our digital twin. And then, and this is an important point, we want to operate the site directly based on the digital twin. So we have this 2-way street of interaction. Now that comes from the fundamental ideas of digital twin from manufacturing and from transportation and so on. You might imagine that we have an airplane's jet engine flying through the skies, and we have in the control room of Rolls-Royce somewhere a digital twin of that engine, and they're monitoring the oil pressure and the speed and the rotation and temperatures and a whole range of data from that engine. And if they need to make any corrections to the way it's running, the digital twin can make those corrections using the telemetry directly into the way that engine is operating while it's flying through the air. So that is the concept that sits behind this. Now, when we talk about the kinds of monitoring we can use in construction, they include a range of different things, from the basic kind of Internet of Things sensors like temperature, humidity, density, quantities, and so on, through laser scanning to build digital point clouds, photogrammetry, which might use 360-degree cameras or other images, through barcodes that might be read through barcode readers on the site, radio frequency IDs or Bluetooth tags that can be sensed by people's cell phones or smartphones or other equipment. Many trucks and tower cranes and a range of other equipment have what we call a black box that monitors the equipment as it's operating. And some of those companies already have the telemetry that we need in order to get that information into the cloud and then into the digital twin for the project. We can also have people on the site using their smartphones to report things and to confirm that something is done or not done, or there's a problem, or take photographs. We also have many construction companies operate enterprise resource planning software, like SAP or others. So purchases of materials, payments of salaries, accounting, timesheets for workers, and all these kinds of things are all available digitally. And not to forget that we also have audio recordings that we can also use. And then we acquire all this monitoring data. And although I show this in a single arrow, we need to interpret it all to try to build up this digital twin. And of course, that's not trivial. That's really complicated. So the complication arises from the fact that the amount of information, the amount of data that's collected here is very, very large. And we can't use that raw data. So what we really want to achieve is this thing called a project status model. Now, project status model is a bit like a BIM on the left here, but a building information model really tells us what is the future of a building. A project status model tells us what's the present and the past of a building. So to go from this raw data through to the project status model, we have to do a lot of work of interpreting and merging the information. And this is largely done with artificial intelligence. And that may be with rule-based systems or with image processing, computer vision, and other things. And so we're trying to go here from data to information. The reason that we want to use the BIM as a supplement for information here is that often it's much more easier to interpret something I can sense when I know what to expect. So if I have a point cloud with points that fall on a particular wall, of course it's helpful to know what the intent was in terms of having a wall in that place. Then I find points on that wall, I can make some logical conclusions about what those data points in the point cloud represent. Amongst the technologies, and I'll just list some very quickly, are things, as I said, like this 360-degree camera on top of a worker's helmet, temperature sensors that are embedded in concrete, which are very common now in many places, laser scanning of facilities and the point clouds that they produce, and then digital reporting by users, this one from Visiline software. And we need to recognize that in the state of the art today, in commercial companies who are offering software and technology and hardware for construction are things like this. This image that I'm showing you here is from a company in the United States called, and what you're seeing on the left, of course, is a video image, still image from a video, and on the right, you're seeing the BIM model. On the left, you can scroll backwards and forwards in time because those videos are taken from a 360 camera every day, so you can go forwards and backwards through the site. You can also then run comparisons. And a similar company, a local Israeli company called BuildDots, offer a similar application. You can see this here on the top part of the screen. You're looking at a plan layout of the building. And the blue dot here shows the vision, the viewport that you can see at that moment. You can see it here in the window, but down here below, you see another screen where we see, again, very similar to what you saw in the open space image. You see here on the left, the actual video transformed into a 3D model. And on the right-hand side, the BIM model of what was intended. And what the software has done here is it has recognized this frame with the white rectangle, and it recognizes that that is intended to be this wall, and it can then tell you, yes, that wall is in the right place. It's being done correctly. On the other hand, you see here dots that are green, yellow, and red, because the software is able, by comparing the model to the actual videos, and by deriving through computer vision what those objects are, and knowing their position and their timing, it can tell you what is missing, what is extra, what is in place, what is out of place. And there are many of these technologies being developed. So BuildUt is a company that is now active in many places in the world. They've raised, I think, a total of $46 million for development, and they're continuing to expand. There are other examples. There are examples of companies who specialize in monitoring tower cranes. And this image here, for example, is from a company called Versatile. So Versatile, likewise, is a company that began as a startup company and are now active in many parts of the world in monitoring tower cranes, but actually they're using it to monitor the state of the project. And it also works in the other direction. Both of those technologies work from the field to the model or to the digital. But here's an innovation that works from the digital to the field. And what we're seeing here in this example is that this is a company called Lytix, and they have a machine that can project the plans or the models onto the floor surfaces in the real world. So you take your BIM model, you load it up on a machine, and you project it directly onto the surfaces, whether it's on a floor, on a wall, on a ceiling, on the roof, or wherever. So we also have technologies for going from the models to the field directly for product work. Now, all of those are, I chose 3 Israeli startups, which have their roots in the Technion, in graduates from the Technion. But of course, the big challenge is this, and I'm going to go back for a moment to here. Each of those applications that you already see being developed, they each fit into just one of these sources at the bottom. None of them do this interpret and merge step, where they take information from multiple sources and create real project status information. It's not good enough for me to know, for example, that here there is a socket, electrical socket missing, or that it's in the wrong place. I really need to know why it's in the wrong place, who put it there, how long it took them, what their productivity was, were there any other objects in the way which forced them to do something different. In other words, there's a whole context of information around that that I need to know to be able to say, okay, what should I do about it? What's the next step? So making intelligent control decisions about what to do is it's not enough to know data or information. You have to have knowledge. And that knowledge has to have the context where you merge all of that information. And we have a separate research project dealing with that. It deals with complex event processing, and I'm not going to get into that now. But what I do want to do is say this. When we think of the digital twin, what we really want to do, because we have a closed cycle of monitoring and operating, we want to use the real-time information streams to enable a closed-loop model of construction control. And the best model we have for that is from lean construction, and that is the idea of plan, do, check, and act, or what is known in manufacturing industries as the PDCA cycle. And of course, we do this consequently. So in every planning and operation cycle, we plan, we do something, we study it, we check it, and then we take some action to change the way we're working, and then we repeat and do that repeatedly until the project is finished. So if I think of this cycle of plan, do, check, act in the context of the digital twin, then actually the first thing we're doing is we're doing digital modeling of a built facility. So we build a BIM model, and the BIM model is not only the product, but it's also the process. So we're talking about not just what we build, but how we intend to build it, and when we intend to build it, and who will build it. And then we build. So we fabricate things off-site, we construct things on-site, and we operate the building site. And then, as I said up to now, we monitor and interpret. So this is the digital monitoring of the facility. We interpret that information using some intelligent software to generate what we call the process and product status. And then we want to evaluate and improve. That's the the act part. We want to evaluate what we've done. We also want to evaluate alternatives for going forward. I have a construction plan up to now, I have a schedule, but if I continue that schedule, what will happen? And if I change the schedule, if I change the construction plan or the methods, what will be the outcomes? And if I can do all that, and I come up with some better plan, an improved product design, then I need to go back to my model, change it in the BIM model, change it in the construction plans, and then use those to build in my next week or month cycle. So on the basis of that idea, we have a process map where we try to lay out the different components and aspects of what we call the digital twin design and construction process. So you can think of it like this. It begins, of course, with the plan, do, check, act, and it's a series of these cycles. So if I do this, I can say, well, our process begins with designing. So I design some product, and I plan a process. When I design the product, what I generate from that is our project intent information. And I'm going to go back here just so for the sake of these definitions. We have here PII, the project intent information. This is what I intend to do. It incorporates the BIM model. This really is the BIM model. On the basis of the BIM model, which is as designed product and as planned process, I then go and build. So I build the building, I operate the construction. That generates a physical twin. I'm generating real buildings. And then I monitor them. And I monitor them using all of those technologies I mentioned before. And they generate for me raw monitored data. Now here, I want to call all this digital side the digital twin, but you can see right away that if this here is the BIM model, the PII, then that's quite different from all the rest of this stuff. So what is the rest of it? It's raw monitored data, which I then interpret, and I have what I call my project status information. So this is past. It includes the as-built product and the as-performed process. It's maintained in a separate database, separately from the BIM model and the plans, which are future-looking. I then can evaluate conformance. Well, what does evaluate conformance means? I can compare what I intended to do with what I actually did. And the difference between them gives me knowledge about the product and the process. Am I on time? Am I behind schedule? Is the construction accurate enough? Are there quality faults? Are there safety problems? All of these conclusions that I obtain by comparing the PII to the PSI, I can call my knowledge about the current state. So we call that the project status knowledge. And then I can do the evaluation perform part, the predict performance. I can take all of that information. I can say, okay, if that's where I am, what should I do next? How can I improve my process going forward? And that section of predict performance, I've chosen today to elaborate on, and I'll show you how we can do this with the goal of then making decisions, understanding the simulation analysis results, which is now knowledge about what I want to do in the future. So it's project intent knowledge. And based on that knowledge, I'm going to redesign, replan, change those things, put them in the PII, build, and continue my cycle. And so if I think of it that way, if I focus for now on the predict performance part, then I'm comparing the project intent information and the project status and knowledge about what the situation is. And I'm going to use those two things to try to predict what might happen in the future. And that will tell me, it'll give me a basis of information for making decisions about what to change, if anything. I apologize for the complexity of these charts, but I will try to break it down. Up here, we have our project status knowledge. Over here, we have our project intent information. And we have a user interface, which I'll show you in a moment. But then what we do is we begin now and we say, first thing we need to know some things from the user, from the construction managers. These things are constraints. They're future constraints. When will equipment be available? When will it not be available? When will resources be available, like workers, like materials? What are the weather forecasts? A range of things that we might know about the environment, about the constraints that operate on our project. On the basis of those constraints, we can generate what we call alternate plans. So I have a baseline plan, my current construction plan, and now I want to generate alternatives. Those alternatives are dependent on my constraints. So I might say, I'm using now 4 crews of floor tiling workers. But actually, if I need, I can have 5 crews or maybe 6 crews. So my freedom of action is to reduce crews or to add up to 2 new crews. Once I've generated some alternative plans, I need to evaluate them. And that we'll do here in the simulation. So the simulation will tell me if you do the A, the result will be B or C or D or something else. And actually, if I can simulate them, I can actually create an optimization loop where I say, oh, if this is my alternative plan and this is the outcome, let me evaluate that, change my alternative plan, run it again, and I can do optimization here with genetic algorithms. And this is a fairly well understood process. So this is not necessarily something new, but the result is we can get new alternative plans, which are really quite good. And then once we have that set of recommended alternative plans, I can present them to users, I can present them to construction managers and say, you know what, we recommend you add 1 flooring crew, you delay the painting activity, you move the tower crane over there, and you change the design of the toilets in the 4th floor. And that's what you should do to improve your project from now forward. So that's the kind of thing we want to achieve. So if you think of it this way, to try and explain it a bit more simply, we're taking, as I said, the baseline plan from the project intent, the project status knowledge of where we are. We have targets and constraints, like we can hire 1 more worker, we can purchase 2 more pieces of formwork, we can change the concrete pump. These are process actions. We can change the method of doing the flooring. We can change the type of facade. We can maybe change the stair elements from cast in place to precast. These are product actions, or freedom of action, things that we can do. And based on all of these, we can generate alternative plans. Now, any given alternative plan is some combination of all of these steps that I might take. And then if I have that database now of alternate plans, I can use my status of the project and perhaps historical data to get the construction plan, the building elements, and the agents that will be working. And I can run an agent-based simulation, and I can predict the performance. And what I'm showing here is the idea that the simulations are not singular, they're multiple. So because it's a random number generated simulation, we don't get only 1 result, we may get hundreds or thousands of results. And so we have a distribution of results for the duration and for the cost, and perhaps for other key performance indicators. And these KPIs can be things like the quality of the flow, the amount of work in progress, the cycle time for individual products, and a range of others. Of course, the distribution will be different for every alternate plan. And so I should be able then to determine which plans have the best distributions. And usually they will not necessarily be the results with the shortest duration on average. They will be the results with the most consistent durations, the most predictable durations. Now, you might ask, what do I mean by the simulations? And I'll give you a quick idea. This is previous research that we have done. And some of you might be familiar with the LeapCon simulation, live simulation game. Well, this is a computer simulation of the same game, but the idea is that you have 4 contractors, and in the computer you simulate how they go through 8 floors of a building, and they build apartments, and as they go, they do different pieces of work. This is another simulation that uses a BIM model and an agent-based simulation, where we see 4 different crews doing flooring and painting and plastering and drywall construction, and the computer can simulate their movement through the building. And of course, this is not it's what we call emergent. That is to say, we don't program where they go, we program their behavior and their decision making. And they then get information from the physical reality of the site. They make independent decisions according to the conditions that a subcontractor might meet on a real construction site, and they go and do the work. And the eventual duration and cost of the project is what we call emergent. And I'll show you just one last one to strengthen the idea. What we're seeing here is a simulation not of one single building, but of an entire construction metropolitan area. This is a model of Hoboken, New Jersey. And each of these rectangles represents a building under construction. This represents 4 years of construction. Okay, so each building has a certain height and a certain number of apartments on each floor. And you see here the colors that are running, they run as each contractor goes through the building. And you see down here that slowly you see the development of the S curves for each project. So you can simulate these things not only on a single building. The reason that we're interested in multiple buildings like this in a simulation is that in any environment, projects compete for resources. So your subcontractor might be working on more than one project at a time. And that means that each project impacts on every other project that's running in parallel. All right. So our issues of our tools for simulation are fairly sophisticated. But of course, now to do it on a digital twin, we need to do it in a far more detailed way. And then the next step will be to get the results and come to the users and say, here's what we recommend. So here are some examples of the kinds of recommendations that the system might be able to make. Increase or reduce the number of workers, machinery, and equipment based on the deadline and the budget. Reduce the cycle time of some construction activities, and so on. And the possible outcomes can be represented in all of these things. As I said before, it's not only the overall cost and overall schedule, as you see here, but things like what is the resource utilization rate of a contractor or a tower crane? What is the productivity? How many non-value added timing waste is there in the project? What are the cycle times for different products and so on? So this is the kind of dashboard that we are now designing with the idea of thinking to ourselves, imagine we have digital twin construction, imagine we're able to do the monitoring and get the status information and do the simulation and get the results. What kind of interface then can we expect to present to construction managers on site to give them an idea of what to do? And what this dashboard is trying to say is this. Firstly, it's asking the user, what do you want to optimize for? What's important to you? Is it cost? Is it waste reduction? Is it uncertainty? Is it earliest completion on the schedule? And what you see here represents the idea that this user is saying, I'm only interested in cost and waste. I don't care how long it takes. So they've marked these two priorities. And subject to those priorities, we tell them, you have a range of actions that you could take. You could increase workers in your concrete crew, or you could remove workers. You can increase the rate of delivery of blocks to the site or reduce it. You can increase the amount of formwork that you have on the site or reduce it, and so on. And they can change those using sliders, because the simulation has found that those are the relevant parameters. You can say, would you like to use a mobile concrete pump or no? And whatever setting you set for these values, it will now tell you when you expect to finish the project, what you expect the waste will be, what the cost will be, and so on. So it's giving you a forecast from today to the end of the project, what might be the outcomes. And if you'd like, on the basis of those selections, to know more information, you can go to some of these buttons on the right-hand side here and get more information. So for example, you might say, if I make those decisions, how different will it be from the previous situation? So my current baseline plan might be here, and my new plan might be here. Now, I don't want to create undue expectations. This is all at this point in our first year of BIM to Twin. These are all system designs. None of the software yet exists. But this is the kind of thing that we imagine for the future, and that we're now designing, and we will be building prototypes. For example, you might say, if I choose these choices of equipment, of workers, and so on, what will be the master plan? How will it look? And we have a current date over here, and everything down here is the future. And we might say, for example, if we're doing a detailed plan for a week, we might say, where are the different laborers going to be, where are the different crews going to be on the different floors of the building through the coming week? And how do we expect the flow of their work to look like? Will there be intersections between crews? Will there be conflicts and so on? And we might also say, what cash flow can we expect? And even we might say, well, tell me also the histogram of the number of workers I can expect to have on site during this coming period. So you can imagine that eventually you might have a project control room that looks something like this. You know, you have a little boardroom, and then around the walls, you have all of these sort of dashboards of the BIM model, the current schedule, some details, and the recommendation dashboard from the digital twin. And you say, oh, I'd like to change this and change that, and it tells you, okay, if you change that, the design will change like this, and the schedule like that, and the outcome will be something. And you make your decisions at every planning meeting, perhaps every week, perhaps every 2 weeks. Now, of course, you can make the leap of faith now and say, this control room does not have to be at the construction site. That control room can be somewhere else. Why not put it in the headquarters building of the construction company? That way we have fewer people on site and they can run it from here. And then you can make another leap of faith and say, well, actually the control room is the same for any project. It's only the information that changes. So why don't we have a team here that manages more than one project? Maybe they manage 10 projects or 20 projects. Maybe each day they focus on one project. Or 4 projects per day, and they can do a site meeting once a week for every project. What I'm getting at is that we may have a change where we get a situation where our construction sites are much more like a factory floor that is very, very heavily automated, but in particular, very heavily monitored in a way that feeds me enough information that I can do remote, I won't say remote control, but remote management. With fewer people, with more efficiency, and with less waste. And of course, leveraging the power of AI to make better decisions and to make more consistent decisions. Now, I should mention that this control room is not a mock-up. This is a real project control room from a project of Mace, which is a big UK construction management company. And this is from a from a computer server center that they built in Ireland, I think 2 or 3 years ago. And they use both BIM and Visilin and other software to do this. So these kinds of construction production control rooms are starting to become real. These are on site, and there's no reason to think they would not be somewhere else. And now you can make another leap of faith and say, who will provide all of this computing power? Who will provide the technology for monitoring? Who will provide all the AI systems? Well, it may be that there will be software or startup companies that offer this as a service. And then a general contractor might be able to subcontract production control to a central platform company that's running the same software for everyone. And that production control company could be a platform, a bit like Uber or Deliveroo or one of these major platform companies. And so the potential exists for digital twins for construction to morph into something we call digital twin construction, where some of the current functions of construction management that are currently run by contracting companies may move to professional platform computer-based AI construction management, digital construction companies. And that's a radical and major change that we may see in the future. But the more we automate the information, the more likely this becomes. So I'm going to stop there and open up for questions.
Okay. Thank you very much, Professor Sacks, for this so inspiring presentation. And I would like to proceed to the questions. First of all, I need to make an announcement in Portuguese. Aviso sobre certificados. Aos que desejarem receber certificados devem estar inscritos e enviar o print da tela do YouTube que contém o horário do evento ao vivo, com o nome completo para o e-mail certificado@iep.org.br. Serão enviados a partir da semana que vem, no dia 23. Okay, let's move on. I would like to ask for one of our panelists, Professor Mendes Jr. Ricardo, please. Do you have any comments or questions to Professor Rafael?
So much comments. It will take more 2 hours for everything. It's such much new information. Temos alguma pergunta no chat para a gente começar ou não, Rodrigo? We have some comments on chat. Maybe some of them, please, first.
Yes, there is a question there. Fabiano Prazeres. In the lecturer's opinion, how to enable corporations and the human capital to insert and model the tool in such a way as to obtain effective results? Rafael.
I'll be honest, and I will say that the role of people working with digital twin construction is something that I'm going to say is not clear right now. In the research that we're all in a number of places conducting in the context of digital twin construction, we're not assuming that there will be more automation of the actual production than there is now, which means, therefore, that workers will still work and people will still operate machines like tile cranes and so on and so forth. And the one place that clearly will be affected immediately is the management level, the site management level. And that relates both to the foreman of construction crews, the site superintendents, the site engineers, construction engineers, project managers, procurement people, designers, and so on. And perhaps the key difference is that, number one, we will make the knowledge or the status of the site transparent to everybody. Nowadays, if you think about a construction site, and many of you are managing construction, and you think about the project you're managing, do you really know everything that happened on that site today? Do you really know the status of the painting on the 7th floor in room number 12 on the west wall? Really, that's quite difficult, and it requires people to move around and see the site all the time. We already have technologies through the 360-degree cameras where I can sit in a site office. Actually, I could sit here in Israel and I could look at the movies from your site, and I could navigate to any room I like at any time I like through the history of the project and immediately see what the situation was and what the condition was. So that kind of information is becoming available not only to you, but to everybody. Not only is it available to everybody, but it comes interpreted. So now I can say, I'm not interested in the paint in room 7 unless it's wrong, or there's something wrong with it, or it's late, or it's early, or it's the wrong color. And because I can compare with the BIM model, I can now get that reported to me directly. So I can say, just show me all the things that are wrong today. I don't have to walk through my building. Just I can quickly, in 5 minutes, see everything that's wrong in my project. So the immediate availability of that information to everybody, the fact that I can call up the architect on Zoom and say, look, can you quickly go with me to room 7 on floor 5? And we both go there on the software and we look and say, oh, we need to change this, change that. Okay, we're done. Within 5 minutes, we have a decision which might have taken days in the past. So it becomes much more immediate. Now, when you add that to the ability to automatically run future simulations and use AI techniques to optimize your future decisions for production control, then presumably you're able to do this better than people can. No human being can think through thousands or tens of thousands of permutations of construction plans, but computers can. And so we expect that people will be presented with better ideas, more consistent ideas for how to manage production control. And of course, eventually, immediately that means that productivity goes up for those people, and therefore we require fewer people. It's not different from computerization of many, many other functions, banks, taxis, I don't know what, even without automation of the production itself. So now, how can companies prepare people for this? How can we change to adopt and absorb these technologies? I want to say, after having given a very long answer, I want to say I don't know the answer. This is probably the realm of researchers who deal with organizational change, with industrial change, and it's clearly not straightforward, not simple. Obviously, we need in our university to teach more technologies in civil engineering, in architecture. We need to teach production control. We need to teach software. We need to maybe have combined courses that are not only civil engineering architecture, but have a good helping of computer science thrown in and production control. And then we may produce professionals who, in the coming years, are better able to work in these environments.
Thank you. Another question, Ricardo?
Okay, thank you, Professor Sacks. I want to compliment him that maybe we have to give more jobs to industrial engineering. Industrial engineering here in Brazil, there are a lot of courses, and they are going to other sectors and services out of engineering. It's not so good. We have a question from Arthur Medeiros. Hi, Arthur, glad to see that you are with us here. Excellent presentation. Could you please, Professor Sacks, comment about bridge maintenance through digital twin?
Yes, sure. Actually, we ran a research project on the topic of digital twins for bridges 4 or 5 years ago. At that time, we did not call it digital twins. I guess the term was not very common. So the project was called CBIM, S-E-E-B-I-M. And then on the basis of that, there was a project called C-Bridge. It's becoming more possible now to acquire the digital representations of bridges and other infrastructure, and then compare them to compile BIM models of their current state, compiled status knowledge, and then to compare them with BIM models. But perhaps more significantly with bridges, is we don't have BIM models for most of our bridges. Most of them are legacy infrastructure that was built many years ago. And so it's more important for us to be able to scan them with laser scanning or photograph them or video, whether using, it doesn't matter what you use to get those images, but you then have to interpret that and compile digital models. And the important thing is then to repeat that every 2 or 3 years, and then compare that and map the deterioration over time. So there are a number of companies that have begun doing this in a very practical way. There is a startup company called Digital Infrastructure. And what they do is they take videos, images, laser scanning of any kind of infrastructure. It can be tunnels, bridges, roads, and so on. And they do exactly that. They use computer vision to compile 3D models, and then they monitor over time, and they provide alerts. If you see a patch of water or moisture, and then over a year or two, it's growing bigger and bigger, they will tell you, well, obviously you have some leakage, or you have some corrosion, or something else. And I think that this is going to become much more common. In the United States, there are something like 550,000 bridges. Throughout Europe, there are close to 600,000 bridges. Many of those, well, most of those bridges are beyond their service life. We saw the collapse of the bridge in Turin in Italy, which was just an example. And the challenge is that there are not enough engineers and inspectors and budgets to continue maintaining them using people alone. And so I think there is an enormous market for engineers and for companies to undertake that kind of digital monitoring, interpretation, and recommendation to maintenance authorities.
Thank you.
Before taking the next question, I would like to take my first one. And before this, I would like to talk some context things before thanking the presence of Professor Sacks with us. And in August, 40 years ago, Professor Shir and I were entering the Federal University of Paraná.
Good, thank you. It's my colleague.
And 21 years ago, we founded an ITC research group, Grupo TIC, and fortunately, we had developed numerous initiatives for the intensive use of ICTs in management of projects and construction works long before they reached the market. And many of them are on the market today, whether through our students or not, what making us very happy. Happier when they are our students, as Bruno from Oak Offsite, that you saw days before this, before today, and Thiago from Palestrante, to name a few, they are in evidence this week. And that's how it was with BIM over 50 years or more, Professor Sushir, okay? It was the first application of line of balance and less partner system in Curitiba after my doctoral thesis in 2000, year 2000 with Norley Baú, with task management apps on site in 2004 with a startup, and leading construction with Karlsruhe University or Institute, I don't know, really.
EMB, Professor Gebauer.
With Professor Gebauer and together with Sinduscom and Sebrae in 2008. And a construction control room with less parent system we did together with Campestrini in an experiment on a real project in 2040. Thiago is today putting on a new room control this week, this month, really. And further in time, it all started with our meeting with Professor Koskela on the third IGLC, International Group for Lean Construction Conference in the winter of 1998 in Guarujá Beach, Brazil. Very much history here. And now it's been with virtual construction and digital twins construction, I hope. So I personally thank you, Professor Rafael Sacks, for your presence today, accepting the invitation to make this extraordinary presentation for us, and for giving us the opportunity to have some insights with our questions that I hope will be good. So my first one, I already mentioned BIM is already a reality on the market today, here in Curitiba also. And it's clear in your presentation that BIM is part of digital twin construction. However, I want to know if all information collected for a digital twin construction will be stored in BIM models or connect with them. When I say BIM models, understand BIM 4D, 5D, and so on. What do you think?
Yeah, you can hear me, right? Firstly, I would say much of what we're talking about here is exactly a continuation of the developments, Ricardo, that you mentioned of lean construction, LPS, introduction of building information modeling, and then project control rooms, virtual design and construction, and so on. So this is part of a continuum. So your question really goes to the idea of where does BIM fit in with the digital twins, and how does this work? And I think what I want to say in that context is the following thing. I'm going to see if I can just show you a different lecture on this.
Okay, please.
Yeah, just bear with me a moment because I want to show one particular slide which was not in the set that that I used. What I want to say is this. You can think of it this way. Let me try here. I'd like to share again, and I'll try and make this brief. Yeah. Is that okay? You can see that?
It's fine.
Give me a moment, I'll share that once again, just to be sure that it's the correct one. Yeah, so you can say this. If you imagine that we have the site and the digital twin, then we have two dimensions of information. We have physical information and virtual information. So we have the physical site and the virtual digital twin. That's the first axis that we find. The second axis we can define is a difference between what there is and what we intend to do in the future. So this axis between status and intent, if you like, is past and future. And in the four quadrants that we now have, we can put here what we call our project intent information, what I call PII. Using the PII, we create a physical status. This is the physical building. And from that physical building, we can monitor and get project status information. This difference between project intent and project status is future intent and past reality. This part is the BIM model. This because the BIM model represents what we intend to do. It's our design. But now there is another axis. You know, if we think, for example, of doing a physical prototype, like a mock-up of a room or a physical mock-up of a window or something, that fits here. That's physical expression of what we intend to do in the real building, but it's only a mock-up. But now we have another axis that I want to show you, and I just skip here for a moment. The other axis we have is between product and process. So we have information about the building we're going to build, and we have information about how we're going to build it. Our schedule, our production plan, our production system, and so on. Now, if we think of those three axes, then we have the physical and the virtual, we have the status and the intent, and we have the process and the product. And now we have 8 quadrants. 2 of the quadrants here at the back, the physical intent, generally we don't have. So we only have these 4. These ones, the building and construction, the construction process, that we understand very well. Those are physical things. The PSI as built and the PSI as performed is all the information about what was done. It's usually in the form of point clouds or measurements and so on. It's not necessary. It can be building objects, but it's not what we generally think of as the BIM model. So these 2 parts here, the PII as designed and as planned, this is what we think of as the BIM, at least what I think of as the BIM model. And you can think of it in this way. If we talk about digital twins as kind of people, yeah, that's our metaphor of people, then people have a lifetime, and twins are conceived and they're born and they grow up and they grow old. And so we can think of it that way. Here is a building project with BIM. We have a start of conceptual design. We design something in this period of time, going from left to right. Then we can start some prefabrication off-site. So we have off-site prefabrication. So we start making things. This blue part is the physical part. And then on the start of construction on the site, we begin building. We install construction plant. That might be a crane and a fence and the formwork and scaffolding and so on. And we also build the building itself. And as time goes by, we add more and more physical pieces. In the end, we have a project that we hand over. Now, at the same time, we're doing design and we're creating a virtual representation of that building. From day one, at the start of design, we start accumulating the BIM models. the products and the processes, the construction plans and the BIM model with all its complexity. But now, once construction begins, off-site and on-site, we begin monitoring what's happening. So we begin taking movies, doing laser scanning, collecting Bluetooth information, RFIDs, barcodes, everything. And that gets compiled in this database. It's the as-built product and the as-performed process. Now, from a principal point of view, we should keep these three things separate in our minds. This is the BIM model. We may have very close relationships between objects here and objects here in our database, because if I have a wall designed and I have a wall as built, I'd like to know that comparison, be able to compare. But that's fairly easy because they have the same location. Now, when the building is finished, we move it into operation, and the as-built information, we move into what we call here the digital twin for operations and maintenance. Now, that's different from the construction digital twin. Over here, there's a transformation of information. And the information about the process, who the contractors were, when they came, how long it took, what was the productivity, plus all the BIM models, they all go into a project archive, which is what we might call our historical digital twin. And we can use that to get useful information for future projects. So what I want to say here is that this is the BIM information, this is the project status information. Although they are very closely related, they're not necessarily the same thing conceptually.
Okay, thank you for your extra explanation. We'll go to the last question. It's from Gabriel Coutre. Thank you, Gabriel. It's the 1 million question. How to change the mindset of the traditional engineers to use new technologies?
If I answer this correctly, do I get $1 million?
Probably.
Probably.
You know, even if you say yes, I'm afraid I don't have the answers. It wouldn't help me.
Oh, you don't get money.
Often people ask this question: how do we change people's mindset? How do we encourage people to adopt BIM, to adopt virtual design and construction, to use monitoring technologies, to use modular construction, offsite, range of questions. And I think that fundamentally, people behave in their interest. Now, I say that very carefully. I don't want to say in their economic interest, because there is a great body of research in behavioral economics which tells us that behaviors are not necessarily what we perceive as being in traditional economics rational. They're often guided or motivated by influences that don't have to do with earning some money or having the best outcome or the best result. They have to do with status, with motivation, with how people perceive themselves, with how they respect themselves, how they think other people see them, and so on, as much as they may have to do with being successful economically. And in construction, that plays out because we have very, very fragmented industry. We have thousands of construction companies, subcontractors, designers, architects, engineers, organizations, software vendors, lean consultants, and all the rest. Those are very complex systems. And it's not clear that we can change them in a very rational way. We've witnessed very recently the collapse of Catera in California. Now, Catera was very much an exercise in trying to reinvent the construction industry, not to change it, but to reinvent it completely. Mm-hmm. And with all the finance that they raised, close to $2 billion, with all the efforts, with all the best engineers, the best computer scientists, and so on, they still were not able to make that successful as a business. I think that we should not take on, either as researchers or as industrialists, we should not assume the job of changing the industry. We should just assume the job of doing the best we can in the best way we can at the moment. Now, that, of course, means we should look at what technologies are available, keep an open mind, and try to innovate. Sometimes we'll innovate and succeed, sometimes we'll innovate and fail. But the good thing is that, and perhaps the key thing here is, there is a strong move now in the construction industry towards startup companies who get investment and they try out new things. The difference between those startup companies and traditional construction contractors is the startup companies, they love risk. In fact, they're designed to take on risk. Venture capitalists exist to take on risk. General contractors are risk averse. They don't want any risk. They'll do everything they can to give the risk to somebody else. So it could be that general contractors are not in a good position to innovate in construction. But by using subcontractors, in other words, service providers who are startup companies, to provide services without risk to the GC, but with risk to the service provider, that may be a good way to go. And I think that that's much more likely than changing the mindset of engineers and contractors. So I think the only mindset change we should make is that we should try to understand that some of our functions may be done better by innovative companies who provide us a service. It's not different from saying, I'm not going to buy a tower crane, I can rent a tower crane. The risk for the tower crane guy is his risk. I don't want that risk. So I'll buy that service. In the same way, I can buy IoT, BIM, and all sorts of other things. They will either succeed or fail, but if they're composed in the right way, they have very good chance of success.
Okay, I have the answer. Turn to 60-year-olds and a magic happens.
Okay. Thank you.
Thank you, Professor Sacks again, and Professor Scheer, it's with you.
Okay, thank you very much, Ricardo, with your help with the questions and some reflections. And I thank very much, Professor Sacks, for your so nice presentation and so nice discussions and answering the questions of our public. So thank you. I pass the words to our President, Nelson, please.
Well, by the end, I hope that we have more time to talk with Professor Sacks. It was a wonderful speech, a wonderful presentation, and give us some questions in our mind about the technology and the future, and about what we receive in our university, in our engineers course. That's a very important thing to, we have some actions to change the way we are giving to the students knowledge about the futures. It's very important. Congratulations, Professor Sacks. I would like to say your speech was an exceptional lecture for us. It was exceptional because you gave us some hope that we have a better future in our career. Thank you, Professor Sacks. Have a wonderful day, and I give you open this moment to the final words, your final words. Thank you.
Very simply, thank you very much for wonderful questions and a great discussion. And if we can look at our everyday work with more hope and excitement for an interesting future, then that's great. We can all go home feeling better.
I look forward to receive you in Curitiba in our institute. Okay. Thank you, Professor.
Thank you. Good morning.
Bye-bye. See you.
Bye-bye.
Good. So,
ele já saiu, professor, já saiu. Parabéns aí, Scheer, parabéns a Clarice, parabéns ao Ricardo, parabéns ao